Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So here is a problem of the day 3. Look at the problem. Triangle ABC is an isosceles right triangle. Angle C is a right angle. So let's just draw it first. C, A, B. DE are on edge CA, CB, and CD equals to CE. So let's find CD here, CE here. The perpendicular lines from CD to AE. So we draw perpendicular lines from point C and D to AE. Meet AB on KL. Prove that KL equals to KB. So we know this is 90 degree, this is 90 degree. Right, okay. So let's just review what we have from the problem set. We know that angle ACB equals to 90 degree. And we know that DL is perpendicular to AE. CK is perpendicular to AE, which means DL is in parallel with CK, right? These two are in parallel. And we want to prove that KL equals to KB. So just because KL equals to DL, just because DL is in parallel with CK and CD equals to CE. So it's very natural that we think of extend C to another point F. Make CD equals to C equals to CF. Right? Let's just assume that LK equals to KB. Right? Assume this is valid, which means LK equals to KB, CD equals to CF. So if we connect FB I think I didn't draw it very well. Yeah, here. If we just connect FB, we should have the conclusion that FB is in parallel with CK, right? Because LK equals to KB, CD equals to CF. So we can think about the problem reversely, that if we can, first we find the point F, right? And we know that CD equals to CE equals to CF. So if FB is in parallel with CK, then LK equals to KB, right? Then the target is to prove that FB is in parallel with CK and in parallel with DL. So let's consider here, we have the DC equals to CE and CE equals to CF. So if we connect them, okay, we want to prove that CK is in parallel with FB, right? That's the thing we want to prove. Which means we want to prove angle DCK equals to angle DFB, right? Angle DCK equals to angle DFB. So because AC equals to CB, CE equals to CF, and angle ACE equals to angle BCF equals to 90 degree. So we know that triangle ACE is congruent to triangle BCF, right? AC equals to CB, CE equals to CF, and this is 90 degrees, this is 90 degrees, so triangle ACE is congruent to triangle BCF, which means angle AEC equals to angle BFC, right? And remember that we want to prove that angle BFC equals to angle KCD equals to this one. And then it's very straightforward because angle AEC plus angle CAE equals to 90 degrees, right? And angle CAE, which means angle AEC plus angle CAE equals to angle CBF equals to 90 degrees. And we already know that angle CFB plus angle CBF equals to 90 degrees, right? That means angle AEC equals to angle CFB, right? This angle equals to this one. And we know this one plus, so angle AEC plus angle CAE equals to 90 degrees, and angle CAE plus angle ACK equals to 90 degrees. So this angle equals to this one as well. So we know that angle DCK equals to angle BFC, which means CK is in parallel with BF, which means LK to KB equals to DC to CF equals to 1. So we got LK equals to KB. Okay, so this was a problem from Russia Math Olympiad in 1974. So you can see the problem today is much difficult than this one. But this is still an interesting problem because when we learn from this problem is that how we deal with so many known conditions, right? Because we know that AC equals to CB and CD equals to CE, and we want to prove these two are equal. We already know this is parallel line, so natural thought is that we find another parallel line here and find all the relationship between segments. Okay, I hope you like this problem. I hope you like this video. See you in next one. Thank you.